Oh, hi everyone. I'm Nikolai. Our good friend Trung asked me to come over here and talk about game development in Ruby, and particularly using the Gosu gem. Um, so I thought, why not? And I will show a few tricks and general use cases how to do that. But first, quick word of disclaimer. Basically, you can write games with Ruby. It's achievable, particularly 2D games with Gosu, but normally you won't. Ruby is not particularly suitable for game development as it is. It's too memory hungry, it's too slow. There are a bunch of other languages which are better suited for it. But you still can do that. Why would you? Is completely another question. Um, I look at it as a way of sharpening my tools. Basically, you can use Ruby to build games, uh, but Ruby is not designed for that. So you kind of using your favorite language in a different use case, which kind of allows you to look at things at a bit different angle, if you will. Helps you to understand the language better, its limitations, its advantages. In particular, when we're talking about game development, Ruby is actually quite a good language. It's very expressive, it's object oriented. You can really neatly describe your business logic in Ruby. It's quite easy because you can overload like operators, setters, getters. It's quite easy. But as I said, it's slow and it's memory hungry. It's not really embeddable. There's not that many libraries that support Ruby. There is no community around it, but you still can do that. I do that from time to time. So today I'm going to talk about building Street Fighter in Ruby, and because it's a rather large build, um, even the first spec of the game took me a couple of hours to build. I'm not going to build obviously the whole game, even the part that I already built. Um, but I'm going to show you basic principles. And one thing you need to be aware of, I'm going to use a little gem I wrote. It's called Git Wayback Machine. It basically allows you to quickly browse the state of any Git repository and switch between states. It's basically, if you can see in the background, the atom editor, as I'm going through, it changes things. So game. See, so I'm gonna cheat from time to time. I'm gonna jump to the next step to show you more context and more things because I don't want to write them by hand from top to bottom, and just it will be just too tedious, and we won't be able to cover much that way. So with that in mind, let's pretty much start. I'll start from empty project. So I'm using the gem called Gosu, and I set up pretty much an empty Ruby gem. There is nothing, it's just like a bunch of things that included here and there. And the main file, basically, there is a bin stop, which then kicks in our start file, and start file just starts the gem, starts the game. Gem file is pretty much empty. It has gem spec, and gem spec has just Gosu. There are no magic, no nothing. Okay, so first, to actually spawn a game, you need to use a Gosu window. You just inherit the class, and then in initializer, you specify the size of your new window, and magic param. I don't exactly remember what's that, but I think it says whether it's show the window decoration or not. But either way, you can figure it. It's in documentation. And then I just assign some caption. So when that's done, I can just boot it, say Ruby Fighter, and it will render. You cannot see it, but it's just a black window. There is nothing on it. It's just a black canvas. So in this regard, Gosu window is kind of your world, right? This thing is like on top of your hierarchy of your game. It governs like physics, inputs. You might have a bunch of objects which you throw into the window. For example, it's actually easy to do game development. The trick to game development really is having assets, meaning pictures. So I've got this set of images from internet. You can Google them. There's a bunch of options available, and then I cut it with some graphic processor into a bunch of what's called sprites. In game development, images, a set of images called sprites for whatever reason. So you can basically take any picture and put it on a window, and that works kind of like that. You just say, let's go dude, and you say Gosu image, new, pass window inside, specify the path of the window of the asset. In this case, assets ru idle one gif, and then magic parameter. That magic parameter basically used for working with sets of images, but in this case I just want one image. And so this way you initialize the image, and then if you want to draw it on a window, you just implement the method called draw, and you say basically dude draw, and you need to specify the position, say 100, and then a magic parameter again, which basically a z-index. Say if you've got a bunch of images on your screen, you need to layer them up so that say characters appear on top of backgrounds and stuff like that. So in this case I'm just specifying 1, 0, and let's see it. So you see there is this dude right there. It's too small to be able to do anything with it, but you actually can scale it. You can specify horizontal and vertical scale for things, and that will change the size of the dude. Here we go, it's a bit larger. And then let's throw in background image. In game development, background image is called backdropped. Same thing, just historically called backdrop for image which is like background. Same thing, goes to image, new self, assets. I've got just one background, one gif false, and now we can draw background. Draw, let's say 0, 0 in a top left corner, as you would expect. I set z-index to 0 and for dude to 1, so dude would appear on top of the background. Let's run it again. Oh, cannot find. Right, it's not GIF, it's JPEG. Let's run it again. Here we go. This image also needs to be scaled proportionally and centered in the window. That is pretty routine, so I'm going to jump to the next commit in my game implementation. As you can see, I added some calculations and positioning around the player and the backdrop, so it would be aligned properly. And let's rerun it. See, now it's kind of looks like a game, like an actual game. So that's easy. The next step is you normally break things up. right? Because you cannot just throw everything into Windows. This class will become a mess. There is also controls, game logic. So normally what the regular pattern in game development, what happens is that you extract your all images like players, backgrounds and stuff into other classes. So I'll just jump there. For example, just extracted backdrop into its own class. See, it's just a class. You can inherit a Gosu image and do logic inside. And then just use it like that, and it will do exactly the same thing. Let's rerun it. See, the next thing you normally do is you extract a player into a class. So as you see, I introduced a class called player, and I give it name for character, in this case Ru, and inside of that class I don't inherit image, because it character class, it will also have character specific logic like movements and damage and animations and stuff like that. And yeah, so I encapsulated, instead of inheriting, I encapsulated image inside of the class. So just name and then rendering it in a specific position and scale. I can go nuts and do things in here. In the end, it does exactly the same thing. See, next thing you normally do with game, you start introducing horizontal movements. See, here I just hardcoded 100 as a position, a left position, but normally you say you need a method to move your character. In this case, I'm just making horizontal movements. You just say move X and X position, and you say introduce per local variable, say position X equals X, and you specify position X, and here move to 0, let's name it 2. And then you can move, pre-move the character I'll move it over here, move to 100, right? And it will do exactly the same thing. But you need methods like that to animate your changes, right? So I'll just jump to the next commit, so it will show you a couple of characters in here and the implementations for the moment. So that should just work. Let's rerun it. So here I've got two characters. The problem is that both characters kind of face the same direction, right? And you need obviously to flip images to the other side, but you don't need to do that through your graphic imager, graphic processor, and create like left and right side of images. We can flip them programmatically. That's easy. That normally done through just specifying negative scale factor for horizontal or vertical, depending on like which way you want to flip it, and that will flip your image. See, now both of them flipped, but so we actually need to introduce now a state for a player, whether it's like on left side or on the right side. So I already have that. It has a bit of, so here's extra param for flip and extra some logic to deal with scaling and positioning, because flipping will happen on the left side, so you need to actually flip image so it would look nice. Let's do that again. Here we go. Now it looks nice. Now you need to introduce actual controls in movements. That usually done through the implementing method called update on a game. So game itself has a thing called game loop. So it basically goes through update, draw, update, draw. Um, in ideal circumstances, game engine will try to squeeze 60 FPS out of this cycle, but it can go slower or faster, but it's still the same cycle. In update, you update your model state, like positioning of your players and stuff like that, they handle controls, and in the draw, you draw that state. So basically, update is for your module, and draw is for your views if you wanna kind of standard MVC like thing, and game window is kind of your controller. So how you actually handle inputs? For that, there are a method called a button down, which takes the button ID, like ASCII ID, which is can be used, but uh, a bit dodgy. To make it a bit nicer for the programmers, it got another method called button char to button ID, and you can give it like actual letter, and it will convert it inside. And in this case, say you can say player one move left, and else if put button down D, right, and you say player one move right. And what happens, you basically implement these methods in here, move left, move right. And you basically iterate on your position. The update method will try to be called 60 times per second, but it depends. So here you just iterate every time it's called and basically move the player position. Let's look how it looks like. A sec, nothing works. Play one, update. Not sure what's the problem, but I'll just jump it. So here I also introduced parameter called speed. One was too small, so I introduced also controls for A, D, K for player 1 and player 2, so that you could play both of them on the same keyboard. That should work. See, we can move both of them. Unfortunately, they will go straight through each other. Well, after that, you normally start to introduce constraints. Show you it. Basically, you specify the positioning of player left, right, and then see if they don't overlap. So on this thing, you kind of start building up your logic. But as you see, this thing is becoming quite messy really quickly. So the next thing you'd normally do in game dev is that you introduce controls. So you introduce a class controls, which has like actual key mapping and actions, and controls basically contain the logic for, well, controls, and they tap into a controller, into window, and you just basically pass your player in and delegate all this logic inside of the controls, right? So it does exactly the same thing, it just separate thing. You can it's like often used pattern, if you will. So one thing I also wanted to show you is how you do animation before we stop. I know we spent a bit of time, but let me show it quickly. Animation is kind of simple. Basically, you instead of rendering just one image in a player, you load up a set of images. Like see in here I've got a bunch of images like for different states, right? So what you do, you load up every image in a set of images, like in this case just a array of 4 images, and in your drawing method you pick up the next image every time and you render it. So every time when drawing happens from scratch. So you don't need to erase image or anything. You just in draw you need to pick one, which done through this a bit weird condition. It's a little hack quite often used in game development to iterate through set of images. So every time, because you see it's modules on size, it will pick the next image. And through this parameter we can kind of specify the speed, how quickly it should happen. So let's see how it happens. See, now they move, and on this basis you can basically build up. Then you extract this thing into a set of into animation engine. You create an engine which basically will handle your animations and iterate through images, because you will need to handle a lot of animations. It's not just idle like kicking, punching, basically anything a character does you will need to animate it, right? So you create an animated agent and then you introduce a tile set for your images. Tile set is basically a set of animations for different states. For example, walking, idle, punching, kicking, whatever. And that thing basically introduces a state. So you will need to flip between states of the player based on which controls are pressed on a keyboard. And that a lot of code. So I'll just show you the final version of the thing. So there is a game, it's updates, still feeds all press down and ups to controls, and the controls, they have key mappings and they decide which action should be delegated to the player. For example, when you press left, right, it switches player to walking. When you raise up a button, it goes to idle. When you press block, it goes to blocking, punching, kicking. So, and then player, based on that methods, it just switches the tile set to a different set of images, which are all here. See, I've got images for hitting, kicking, punching, walking, and it's all kind of, well, routine at this point. You can build up on the different things. So, and this is how it looks like. See, you can walk back and forth, you can punch, you can kick, and girl can move around, she can block, and she can kind of bitch slap the dude. One funny thing, back in the days, they didn't have enough memory. So what they did, they would draw the walking animation in the ways that it would look the same whether you're moving forward or backwards. It's actually the same image set, it just it makes this illusion that it's actually working forward or backwards. Like, just funny thing to know. Anyways, that's how you build this stuff. This little engine is basically you can build on top of that, add more movements. You can introduce in player damage control, so you can actually start like calculating health and damage and distance between players and all that stuff. But as you can see, you can start easily. All you really need is to know the basics and a set of images. That's pretty much the whole thing. Yeah, I think I should wrap it up at this point. Thank you for watching. The actual game, it's on GitHub. It's just called Ruby Fighter. Just Google it. It's in there. You can go check it out, play with it yourself. If you end up actually extending it, send me a pull request, I'll gladly merge it. Um, Otherwise, that's pretty much it. Have fun, maybe see you around.